Hello, in this video, I would like to talk about the closeness centrality in social networks using the Excel file that's uploads 2.3 social network analysis not class Blackboard page. And in my previous video, I downloaded the 16 social network adjacency.xlsx file, and I would like to continue working on that file. First, we did calculate degree of centrality. Now I would like to calculate the closeness centrality. So here, this is a little bit harder than the degree of centrality. We need to look at here each person. Let's start with Alex and find the shortest distance. So Alex connected with himself. Obviously, that's not gonna work because himself, right, or herself. So that's why all the diagonal elements are zeros here. Zero, 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 because people cannot be connected themselves. Uh, so now what I'd like to do is look at another edge connecting Alex to Jamie, and you can see here it says 1. Why does it say 1? If you go back to adjacency matrix, Alex and Jamie are directly connected, so they should their shortest path is 1. So same thing for Taylor. So I will put Jamie and Taylor 1, as you can see, 1, 1. And similarly, what I can do is go back to let's say Jamie. For Jamie's row, I will put Alex 1 and Taylor 1 and Jordan 1 because they're directly connected. So you can see Alex, Taylor, and Jordan 1. So where does this 2 come from, right? Again, I will show you also calculations, these calculations via Python, which will be, I think, much faster and efficient. But I want you to understand the intuition. So Alex and Jordan, it says 2. Why does it say 2? Because if you go to adjacency matrix, Jordan is not directly connected to Alex. So I need to look at the shortest path. So Alex is connected to uh, Jamie, and Jamie is connected to Jordan. So that means that Alex is connected to Jordan via Jamie. So it's the second degree. That's the closest path. So that's why we put here 2. And for example, Alex and Morgan, they are connected in third degree. Okay. So once you create this matrix manually, I'm just showing in Excel how to illustrate it. Again, it takes time. You need to go through every single combination, every single edge, and to be able to calculate shortest path. Once you create this file by going through every single cell here, which is 6 by 6, 36 entries total, then we calculate the sum of each row. So if I go sum of the row for Alex, that's 9, and I can drag it down, and you can see these are the sum of shortest distances. Now I would like to convert these numbers to closeness of centrality, and obviously these numbers, the lower the better, right? If it's lower, that means that you are more connected to people directly. So that's a good thing. Okay. So now close to centrality, basically look at the those values. In this case, we look at this sum of shortest distances for Alex, which is 9. If that number is greater than 0, that means that if that person is connected to at least one person, then we count all the entries in our adjacency matrix, which we have 6 entries, minus 1, because again, somebody cannot be connected to himself or herself. So 5 divided by this number. So 5 divided by 9. Otherwise, we'll just put nothing, because if somebody is not connected to anybody, we will not put any number here. So 5 divided by 9 will give us this number. And here 7 divided by 5 will give us this number. 5 divided by 7 will give us this number right here, and so on. So you can see the closeness of centrality is highest for Taylor and Chris, and the lowest for Morgan. Okay, so again, if I look at these numbers one more time, in degree of centrality, the highest numbers were for Jamie and Taylor because they had the most number of connections, Jamie, Taylor, and Chris. And here, Jamie, not necessarily in top, at the top, so it can change because again here this algorithm gives more weight not on the number of connections, instead least number of connections or more direct connections is more valuable. That's it for this video. Until next video, enjoy business analytics.